This lecture, we will see the concepts of Newton-Raphson load flow solution. We had already found the power flow equation. We know that from the power flow solution derivation, let me show you that you can see from this II is equal to VI into, I had already said, summation J is equal to 0 to N, J not equal to I, Yij can be written as Yii, that is here. So we can write this as II is equal to Vi Yii minus summation J equal to 1, J not equal to I to N, Vj Yij. From this power flow equation, that is what I had written. From this derivation, what I can do, I can write this as, since you can see that here there is J is equal to 1 to N, J not equal to I. If J is equal to I, this term becomes as Vi into Yii. That is what here is there. So I can write this total expansion as summation J equal to 1 to N Yij into Vj. Now, this equation, when we convert this into polar form, what we will get? Summation J is equal to 1 to N Yij and Vj into, actually Yij can be equivalent to modulus of Yij into at an angle of theta ij. Theta ij is the angle of Yij, whereas del j is the angle of Vj. So when we are converting this into polar form, we will get Yij is equal to modulus of Yij into theta ij. Vj is equal to modulus of Vj into theta del j. Now, when we had two angles multiplied, they will be added. So, II is equal to summation J is equal to 1 to N, Yij, Vj at an angle of theta ij plus del j. Now, we know that S is equals to P plus JQ, which is equal to V into I complex conjugate. Now, if you apply conjugate on both sides, P minus JQ is equals to V conjugate into I. As I had said, V is equals to V at an angle of del. Since here we had Vi, Vi can be written as Vi, modulus of Vi at an angle of minus del I. Why? Because here we had complex. Conjugate is there, Vi conjugate. So it will become minus del I. Now, II we had just now derived. II is equal to summation J is equal to 1 to N Yij Vj at an angle of theta ij plus del j. Now I am writing that here. So Pi minus Jqi, which is equal to Vi at an angle of minus del I, that is V conjugate into summation J is equal to 1 to N Yij Vj at an angle of theta ij plus del j. Now, from this, I am sending this modulus of Vi into the summation. Why? Because it doesn't mean anything. Since this modulus of Vi does not contain a j term, we can write either outside or inside. I am writing this also inside. It will become summation J is equal to 1 to N Vi Vj Yij at an angle of theta ij plus del j minus del I. Now I am equating the real part and imaginary part. You know that real part of an angle is cos of that angle and the imaginary part of an angle is sine of that angle. This total includes the magnitude, and this angle, when we are converting into real and imaginary parts, real part will get cos theta and the imaginary part will get sine theta. So Pi is equal to summation J is equal to 1 to N Vi Vj Yij and cos of this angle and this angle, that is cos of theta ij minus del I plus del j. Similarly, minus qi, if you observe, the imaginary part in this side is minus qi. Minus qi is equal to summation J is equal to 1 to N Vi Vj Yij sine of theta ij minus del I plus del j. So I am sending that minus this side. Now we got Pi and Qi formulas. These are the formulas used in Newton-Raphson load flow studies. Now, from this, we had this formula, PI formula. From this PI formula, now I am differentiating this PI with respect to del I, that is this term. If I differentiate PI with respect to del I, since there is no del I in this magnitude, they won't be changed. One more thing is, when I am differentiating with respect to del I am splitting this total summation into j is equal to 1 to n, j not equal to I, and j is equal to I. When j is equal to I, what will happen? Vi into I, and this minus del I plus del I gets cancelled. Cos theta I will come. What we will get? Vi square I cos theta I will come. Since there is no del I term, when j is equal to I, this j becomes I. So del I gets cancelled. So during the differentiation of Pi with respect to del I, we need to exclude that j is equal to I term. J is equal to I term will become 0. So the summation becomes summation j is equal to 1 to n, j not is equal to I, Vi, Vj, Yij. Since del I is inside the cos, differentiation of cos is minus sign. And we had a negative sign before that. Minus into minus becomes plus. So sin theta ij minus del I plus del j. So whenever you are finding dou p by dou pi by dou del I, this is the formula. You will understand why we are using this when we go for the problems. In Gauss-Seidel, what we will do, we will be forming a Jacobian matrix, and the diagonal elements of the Jacobian matrix include this. So instead of remembering all the formulas, you just understand the derivation and then you can derive whenever it is necessary. Now, J2 is dou pi with respect to dou v. In this I. So if you see in this equation, we had Vi here. So if you differentiate this one with respect to Vi, again, we need to split this term summation into two parts. J is equal to 1 to n, j not is equal to I to n. Why? Because when j is equals to I, it will become Vi whole square. So Vi whole square Yii cos theta I will come. So j is equals to I case. When you differentiate this with respect to Vi, you will get 2Vi Yii cos theta I. This is j is equals to I case. When j is not equal to I, if you differentiate this one with respect to Vi, it is like Ax. Differentiation of Ax with respect to x is A only. So this term will be gone. Summation j is equal to 1 to n, j not is equal to I, Vj Yij cos theta ij minus del I plus del j. Now, similarly, we had Qi. Now, Qi, we are going to differentiate this Qi with respect to del I. When we are differentiating Qi with respect to del I, we had del I here. Again, we need to split into j is not equal to I case and j is equal to I case. When j is equal to I, what will happen? Minus Vi whole square Yii sin theta ii. Since the minus del I and plus del I gets cancelled, when we are differentiating Qi with respect to del I, j is equal to I case becomes 0 as they both cancel. J is equals to I naught, del I and minus del I gets cancelled. So that term will be 0. So excluding j is equal to I condition, summation j is equal to 1 to n, j naught is equal to I, Vi, Vj, Yij. Differentiation of sin theta is cos theta. Cos of theta ij minus del I plus del j. And since we had a negative here, by using chain rule into minus 1 and this minus multiplied to give plus. Then when we are multiplying this with respect to, when we are differentiating this with respect to Vi, what will happen? Here we had Vi. Again, we need to see both the cases. That is, when j is equal to I and when j is not equal to I. When j is equal to I, what we will get? Minus Vi whole square Yii sin theta ii. That when we differentiate, what we will get? Since x square. When x square is differentiated with respect to x, we'll get 2x. Same thing. When minus vi whole square yi sin theta I is differentiated with respect to vi, minus 2vi yi sin theta I. This is j is equals to I condition. Coming to j not is equal to I condition. When j is not equal to I, same. This is f. Differentiation of ax with respect to x is a. So just this will be gone. Minus summation j is equal to 1 to n, j not equal to I. Vj, yij, sin theta ij minus del I plus del j. When we are differentiating with respect to del I, since del I is in the sign, we will be borrowing about this sign term. When we are differentiating with respect to vi, since vi is in the magnitude, the sign term will remain as it is. Now we have differentiated with respect to same. Now let us differentiate this del pi with respect to del I. We will see here. Now here, when we are differentiating pi with respect to del j, before we saw pi with del I, pi with vi, qi with del I, qi with vi. Now we will see pi with del j. You will understand why I am differentiating all these once you will go to Jacobian matrix. When we are differentiating pi with respect to del j, since we had del j here, what we will get? See here also, when j is equals to I and j, actually you see carefully. Yeah, if you see carefully, suppose let me take a number to understand more clear. This I is 2 and j is 3. Now you have P2 is equal to j is equal to 1 to 3. V2, V3, Y23 cos theta 2 3 minus del 2 plus del 3. Now in this, if you wanted to differentiate this pi with respect to del I, sorry, with respect to del j will be coming in only a value of j. That is, if you want to differentiate pi with respect to del 3 will be occurred in this only when j is equal to 3. In this summation, the summation can be expressed as j is equal to 1 plus j is equal to 2 plus j is equal to 3. If you want to differentiate pi with respect to del 1, only first term will have del 1. Remaining terms won't have. So remaining terms when differentiated will give 0 as they are constants. So what will happen? Now in this case, when we are differentiating pi with respect to del j or vj, the summation will be removed. Only the particular term is considered. What will happen? Now, yeah, if you see here also we need to check for j is equals to I and j not is equal to I. When j is equal to I, what will happen? Del I and minus del I cancels. So same, it will be coming 0. When j not equal to I, when we are differentiating, remove the summation. You understand, when pi is differentiated with respect to del 2, when we will get del 2, when j is equal to 2, we will come del 2. When j is equal to 1 and j is equal to 3, del 2 won't be present in the j equal to 1 case and j equal to 3 case. So they will be 0. Only j equal to 2 case will come. So remove the summation. Now what will come? Vi, Vj, Yij. Cos differentiation is sin. So sin theta ij minus del I plus del j. Since here plus into plus 1. That's what given here. See, Vi, Vj, Yij. Sin, sorry, cos differentiation is minus sin. No, so minus sin theta ij minus del I plus del j. This is j not equal to I condition. All when j is equal to I condition, it will become del I and del plus del I minus del I cancels and it will become 0. Whenever you are differentiating p or q with another bus, here you had ith bus, when you are differentiating with respect to jth bus, automatically that jth bus will be only one bus in the summation. Other terms will be 0. So summation won't be present. Now we had differentiated pi with respect to del j. Let us differentiate Pi with respect to Vj. When you differentiate Pi with respect to Vj, again, suppose if you want to differentiate P2 with respect to V3, V3 will be present only when J is equal to 3 in this summation. J is equal to 1, J is equal to 2 will get cancelled. So, again, here we should take the two conditions. J is equals to I. When J is equals to I, what will happen? Vi whole square or Vj whole square Yjj cos theta Jj. And when J is not equals to I, what will happen? When we are differentiating with respect to Vj, what we will get? Vi Yij, as it is Ax differentiated with respect to x. Vi Yij, and then cos theta ij minus del I plus del j. That is what we had taken. Similarly, for Qi, then we are differentiating with respect to del j. Del j will be presenting only one term, so summation will be gone. Minus Vi Vj Yij, sign differentiation is cos. So cos theta ij minus del I plus del j. That's what they had given here. Then when we are differentiating Qi with respect to Vj, what will happen? Vj will be presenting only a particular term. So again say minus Vi Yij sin theta ij minus del I plus del j. That is, it is similar to Ax differentiation with respect to x. The same thing. So if you see, totally we had 8 formulas, actually 10 formulas, Pi formula, Qi formula, Pi with respect to del I and Pi with respect to Vi, Qi with respect to del I and Qi with respect to Vi, Pi with respect to del J and Pi with respect to Vj, Qi with respect to del J and Qi with respect to Vj. So to avoid confusion, it is not easy to remember all the formulas. So if you remember this Pi, Qi alone, you can derive different formulas, that 8 formulas, using the concept I had explained. You not even remember this Pi, Qi also. If you remember the power flow equation, just click these terms to get a overall summation, convert that into polar form and equate it to Pi minus jqi into here. Using this procedure, you will be able to understand all the formulas. Now, let me explain. Okay, first of all, with this, the formulas, concepts and formulas, understanding of Newton-Raphson method is clear. Now, let us see what is a Jacobian matrix and let us solve problems in the next lecture. Thank you.